Okay, we'll wait a couple more minutes because the link just went out. Okay, maybe 2 more minutes. We'll see how many participants we get. We have 20 already, so I believe that there's 21 on my roster. So I think we're almost good with everybody. Okay, if anybody needs the notes for today, I did send them out. If anybody needs them though, I can post that in Zoom here. So let me just post that anyway, just in case somebody doesn't have access to them. These are guided notes, so you can just kind of follow along. You can write down the answers on a piece of paper and then go back and fill them in if you want. So there's the notes for today. Feel free to download that if you don't have them. Okay. We're going to be going through chapter 1 today. Again, you don't have access to the homework yet because you're not registered for the college yet. And I'm not in administration, so that's not really up to me. So they're still processing your paperwork, I guess everybody. So you're neither on my roll sheet for the college or in Canvas, which is where all your homework is assigned. So I don't know at what point you're going to have access. Hopefully within the next couple of days. I've got to follow up with admin on that as well. You know, I may just not count chapter 1 homework depending upon when you get access. Chapter 1 homework may just not be counted, which is fine. You'll still have access to it. I just won't count it for a grade. If it comes to, you know, Saturday and you still don't have access to the homework, the chapter 1 homework is really simple. Shouldn't take you very long at all to do, but if it gets to the weekend and you still don't have, you're still not in my class, then I'll just make that homework not required. You'll still have access to it, so you can study with it, but it just won't be required. Because I'm not going to require something you don't have access to. Okay. What else? I was talking to Mrs. Fleming, I believe her name is. Is that right? Okay. And telling her that I would be interested in running a part 2 of this class in the spring, and that would be Math 219 statistics. So at the same time, and hopefully by then it would be on campus. So I would be coming to your campus from 2 to 3:30 in the spring. So it's just a thought. If you're interested in continuing and actually fulfilling a statistics requirement in the spring, that might be something that could be offered at Samueli. Okay. So we are going to be going over chapter 8 and 9 and 10 of chapters 8, 9, 10, and 11 of the book is probability and statistics. So if you do well in the last portion of this class, you'll be extremely prepared to take Math 219 and do very well in that as well. So you'll be able to get two college courses done in a year's time, if that's something that you're interested in. Hopefully senioritis doesn't set in and you just like, oh, I just don't want to do any work. And, forget that Professor Holtman guy. I've heard all of his dumb jokes. It's just not going to happen. We'll see. We'll see what happens. The year is young, and so are you. So we'll see what happens. I'll just play it by ear from now on. Okay, I am going to give you right now the chapter 3 notes that we're going to be covering. I'll also send this to you in an email. There is one person who I still don't have their email address. I don't know if that person is here or not. But let me see who that person is. Where is that person? So if you know this person, please have them get in contact with me through my email address. If the person is here, then that's fine. Come on, where's my stuff? There it is. Okay, so Edson Ortiz. Is there an Edson Ortiz? Does anybody know an Edson Ortiz? No? Okay, I'll have to work with because for whatever reason, his or hers or theirs email address is not working. So is Joyce here? No Joyce either? Okay. Well, we'll see. We'll see what happens. Okay, I believe it was Joyce. What was the other one? Yeah, Joyce. Maybe it's Ortiz Edson. I don't know. Ortiz Edson. Ortiz is maybe the first. Who knows? Maybe that's why the email address is not working, because they're backwards. I don't know. There's Joyce Banda. Anybody know Joyce? Yeah.
I know her, but she's not in the class, I think, right now.
She's not in the class anymore?
No, not right now. I don't know if she's
taking a different section?
I'm not sure. I just know that she is a senior at our school.
She's a senior at her school. You just don't know if she's in my class. Okay.
Yeah.
Okay, perfect. Okay, that's fine. I just wanted to make sure that, because they sent me the roster, but those two people's email addresses are not working. Joyce was here on Monday, I think. Okay. She joined last class. Okay. Okay, sounds good. I did get, and Edson is also a senior. Yeah, I'm pretty sure. So if you know Edson or Joyce, please have them contact me. Here's my email address. I'm sure you guys already have it, right? Okay. Oh, his email is blocked. Oh, his account may be blocked, disabled. Okay. I won't. There's obviously a story there. I'm not going to ask it. So, yeah. Okay. And then the other thing. That's about it. From me to everyone. Oh, everyone. There we go. Okay, so I'm going to give you the chapter 3 notes as well. So feel free to download these as well. Okay, so these are what we're going to be going over on Monday. Okay. Okay, let's jump into chapter 1 notes. And we'll get into the, was anybody able to successfully print these off or download these, or? Okay, we good? Okay, awesome, thank you. Okay, perfect. That makes it a lot easier because then I can just kind of speed through them because there's really not a whole lot in chapter 1 that I really want to cover anyway. Okay, as soon as I am notified that you guys have access to Canvas, I'm going to email you directly, okay? The moment I get, can't even see my face. Okay, the moment that I get notified by the school that you are enrolled in my course, that second, even if it's 3 o'clock in the morning, I'm going to send you an email that you're in Canvas. Okay. Okay. Yeah. Okay. With that said, let's get to work. Oops. Did not need to do that.
This meeting is being recorded.
Yeah, I know it's being recorded. Thank you very much. Okay. Okay. So here we go. Let's share this guy. Share this bad boy here. Okay. Okay. Hopefully you can see my screen. Okay. So chapter 1 is we're going to go over problem solving. Okay. Do a little problem solving here. Okay. Calculating percents. Okay. Percent means per 100. Percent is to be a percent is like 1 cent of a dollar. When we write 40%, this is equivalent to the fraction 40 out of 100 or the decimal point 4. Notice 80 out of 200, 10 out of 25 are also 40%. Those are called equivalent fractions. So these are equivalent fractions. Okay, those are fractions that equal each other. Well, we're going to set up something called proportions, which deals with one equivalent fraction equaling another equivalent fraction. So that's a proportion. We'll talk about that in a little bit. Okay, so if we have 2 equivalent fractions set equal to each other, that is called a proportion. Okay, if 345 people out of 500 say they like sea turtles, what percent is this? 345 out of 500. Okay, I'm going to divide that on my calculator. I'm going to get 0.69 or 69%. Okay, so if I bring up my calculator, okay, you just divide. Okay, again, this is elementary school math. I don't expect anybody to have a problem with this, but we always need to learn how to crawl before we learn how to walk, right? So I just want to make sure that everybody's on the same page before we do get into more challenging information. Okay, again, we need to know how to crawl before we know how to walk. Okay, so I'm going to clear this out. I'm going to go like this. I don't know. Okay, let me move this over. It's kind of a better, this is a better screen in a way. I want to kind of minimize this, to be honest with you. Make it a little more centered. There we go. Okay, so there we go. Okay, so here's my calculator, right? So this is my TI-84 calculator. And what is this? This is going to be 345 divided by 500. okay, is 69%. Multiply by 100 to get the 69, okay, and we're good. Okay, let's move on to the next one. Let's write, okay, let's write this each as a percentage. 14. Well, when we're given a decimal, we move the decimal place over twice and add the percentage. So this is 1400%. Okay. What about this guy? This is 0.02. Move the decimal over twice and add a percent. That's 2%. Again, this is 7th grade math. I get that you guys are not in 7th grade. You successfully passed 7th grade, but again, just want to make sure everybody knows how to write a percentage. What about 2.35? What is 2.35? Go ahead and put that percentage in the chat box. Okay, Ricardo says 235. Anyone else? You agree, disagree? Okay, Lainey says 235%. Thank you, Lainey. Okay, yeah, it would be 235%. Good job. Thank you, Sasha. Okay, Monique, what do you say? You look real enthusiastic about learning percents all over again 5 years later. So there you go. Thank you, Monique. That's good job. She's like, I'm going to turn my camera off now. So no, could everybody turn their camera on? I'd like to see your smiling faces. Make sure you're not like, you know, playing with the cat or something. That would be good. So just, you're eating, but okay. Okay, well, that's fine. What are you eating? Are you going to share? You can't because it's COVID, but that's okay. Okay, fine. Okay, thank you. Thank you. Okay, let's move on, shall we? Let's talk about percents. Percent is a part over a whole. Normally, it's the part over 100, right? That's what we call a percent. It's the part over a whole. Okay, let's calculate some percents here. A TV originally priced at $799 is on sale for 30% off. Okay, 30% off. If the sales tax is 9.2, find the price of the TV reflecting the discount and including the sales tax. Okay. So there's a couple ways that we can do this. We could say that because it's 30% off, that means how much of the price remains. How much of the price is going to remain if it's 30% off? Thank you, Lily. Yes, absolutely. The 70% remaining. Does that make sense? If I took a piece of paper, and I wanted 30% off, right? I took 30% off. Well, am I paying tax on the 30% that's gone? Or am I paying tax on the 70% that's left over? Aren't I paying tax on the 70% that's left over? Don't I care about this 70% and not the 30% that I don't have to pay on? Does that make sense? So if 30% is off, 70% is actually what I have to pay. Okay, so there we go. Okay. So we're going to say that what is 70% off of $799? Well, that's the percent times the whole is the part. So this is 0.70, which is equal to, okay, bring on my calculator again, 799 times 0.70, that's $559.30. So we got $559.30 here. Okay, so 559.30. That is the price that I'm paying. However, Uncle Sam wants his money, right? He didn't say, "Oh, you're going to walk out of the store paying $559." Heck no. Uncle Sam wants his money, so we have to do what? We have to pay something called sales tax, right? We've got to pay the sales tax on this. How can I calculate the sales tax? Anybody have an idea? How do I calculate the sales tax on this? Anybody willing to share how we would calculate sales tax here? Don't be shy. Okay. Okay, multiply. Okay, that's good. Multiply what? What should we multiply, Joel? %9.2%. Okay, so multiply 9.2% times what? Okay, perfect. Okay, so we're going to say the tax is equal to the 559.30 times 9.2%. So how do I do that? How do I multiply this times 9.2%?
Make it into decimal.
Make it into a decimal. Very good. Awesome. Okay, so what is 9.2% as a decimal? Yeah, it's 0.0. Thank you, Cassidy. It's 0.092. So we're going to multiply this and we're going to get the tax, right? We're going to get the tax because we got to pay the tax man. Okay, there's two guarantees in life, and that is death and taxes. Everybody's going to die. Everybody's going to have to pay taxes. That's it. There's only two guarantees. Okay. Sorry. Just the way the world works. Okay. So 559.30 times 0.092. Again, let's do. Oh, look at that. I don't even have to put in the 559 because I can just hit add. Because this calculator special, it stores the previous answer. Cool. Okay, so if you want to invest in one of these calculators, I'm not going to stop you. Okay, especially if you want to go on to statistics, it would be a good investment. Okay, so anyway, the answer plus, okay, or sorry, not plus, multiplied by. Go back, multiplied by 0.092, okay, 0.092 is equal to $51.46. We're going to round to the nearest cent. Okay, $51.46. Does that make sense? Okay. Yes? Make sense, Sasha? Make sense, Lily? Make sense, Sean? Okay, again, if you have a webcam, please put it on. I would like you to interact with my class. That would be awesome. Okay. Thank you. Thank you, thank you. Thank you, Caitlin. Okay. Perfect. Thank you, Ricardo. Okay, so what are we going to do now? Aren't we going to add these two numbers together? Can we go 559.3, oops, 0.3 plus, and I'm going to cheat. I'm going to go second enter, or sorry, second negative sign. That's the previous answer. So this calculator always stores the previous answer as answer. So that's the second key and then the answer key. Okay, and then I hit enter and look at that. Oh, okay, so it's $610.76. This was equal to $51.46. And then I would have to add that to 559.30 and then ended up with $610.76. Now, there is a faster way to do this. If you wanted to know, okay, or like, well, what's the faster way to do this? Well, the faster way to do this is instead of doing the 559 times the 9.2%, what I'm going to do is I'm going to multiply the 559 times 109.2%. Why 109.2%? Any ideas? Because what's 100% of 559.3? Sorry, this should be 559.3. What's 100% of 559.3? Well, isn't it that just itself? Right, it's in 559.3, 100% of that, right? So what this does is it allows me to combine two steps in one. And if I take 559.3 and I multiply by 1.092, move the decimal over twice, what this allows me to do is in one step, I can find the answer because it retains the original amount plus the tax. Does that make sense? Okay, thank you, Cassidy.
Yes. Yeah. Yes.
Okay, thank you, Edsel. Okay, yeah, 559.3 multiplied by this. So you know, when you're out with your friends and family and they're like, oh, can you calculate the tip on my bill? You know, and how much it's going to be, how much the tip and tax are going to be. Then all you do is you just add 1 to the percentage, right? And that'll give you your final. You skip a step by having to add. The way this works is if you remember back to algebra, right? 559, I keep missing the 0.3 here, 0.30. Okay, 559.30, could we write it like this? Is that the same thing? Could I write that as an equal sign there? Is 1.092 the same as 1 plus 0.092? Isn't that the same thing? No? Yes? What's 1 whole plus 0.092? Isn't that the same as 1.092?
Yes.
It is, right? Do it on your calculator if you're not convinced. If you're not convinced, what's 1 plus 0.092? Isn't that 1.092? Does that make sense? Right? So let's think about this. Anybody ever heard of the distributive property? The distributive property, yes, we've heard of the distributive property where we're distributing, right? Distributing. So couldn't we take this and distribute there? And so what does this tell me? This tells me that that 100% of 559, 1 is equal to 100%. 100% of 559 is equal to 559.30 plus 559.30 times 0.092. Well, what does this represent? This represents the sale amount, right? The amount on sale. This is the sale amount. And what does this represent? 3 little words, 3 little letters. What does this represent over here? Tax, exactly. Thank you, Cassidy. Cassidy is on it today. Okay. Okay, it's the tax. This represents the tax. So can't I just combine them into one expression here? Okay, one expression. Okay. Yeah, we can. Okay. Let's talk about percent increase and percent decrease real quick. Okay. Let's talk about percent increase and percent decrease. The value of a car dropped from $7,400 to $6,800. What's that called? Anybody know what that's called? What is it called when something lowers in value?
Devaluation. Devaluation.
Close. Does start with a D. Anybody know when something goes down in value? What that's called? Decrease? No, that's a little bit too generic.
Devalue?
Devalue? No. Deflation? No, not. I mean, that's when you're talking about other things. Okay, it's called depreciation. It depreciates in value. It goes down in value. Does that make sense? Okay, have you heard that word before? Depreciation, something to depreciate means to go down in value. Okay? Okay, so if something appreciates, that goes up in value, right? What are a couple of things that appreciate? Anybody know of anything that goes up in value over time?
Classic cars.
Classic cars? Yeah, they kind of depreciate and then they go up. It depends on how classic. Does that make sense? Like if it's over 50 years old, then you're going back up. But if it's less than 50 years old, right? Okay, is it Jose or is it Joshua?
It's Josue.
Josue.
Josue. Sorry, I will
Yeah.
I will learn your names. I promise. Okay, Josue. Got it. Okay, so Josue said absolutely correct. Real estate appreciates. Anything else? Anything else that goes up in value? Stocks, not necessarily. Stocks could go down in value, right? That's what happened during the Great Depression, right? What about diamonds? Diamonds go up in value. What about gold? Precious metals. Those appreciate every year. They actually go up in value. Rare metals, gems, they go up in value as well. Okay. What goes down in value? Basically anything else that you could ever purchase goes down in value. Okay. So cars, clothes, technology, right? There's nothing more worthless than a 10-year-old computer. Right? You're like, I'd like my iPhone generation 2, right? You're like, okay, I'll give you $5 for that. My iPhone generation 2 from 2008. Like, no, it's not. You're gonna get no money for that, right? Okay. I want that Gen X. Okay, so this is depreciation, goes down in value. Okay, so what percent decrease of this is this? So percent increase, decrease is the difference over the original. Okay, it's the difference over the original. The difference over the original. Okay. And then we're going to multiply that by 100. Why are we multiplying that by 100? Because we want to get a percentage, right? Percentage as our answer. Okay, so let's find the difference of this and divide by the original. So the difference is $7,400 minus $6,800 all over the original, which is what? Which one is the original here? Which one's the original? The difference over the original. Yeah, the original is 7,400 because it dropped in price, right? It was at 7,400 and it went down to 6,800, right? So over time, T is time, okay, and maybe we'll let this be V for value. Hey, Josh. Josh. Come here. You want to say hi to my class?
No.
Okay, fine. Be that way. He's a high school senior too. Just thought he'd like to wave, but whatever. He's antisocial. He's part of the I don't want to have anything to do with my parents' club. So anyway, I thought I would share. But should I be teaching? Shouldn't you be learning?
No, I'm done.
You're done for today? You're go away and be a lazy bum. Okay? Go binge on your Funimation there, bro. Okay. Yeah, the original is 7,400. So let's do the equals 7,400 equals and then multiply by 100. So let's do this on the calculator real quick. 7,400 minus 6,800. Now, I can hit enter here, or I can use parentheses. If I hit enter, then I know that this is 600, a difference of 600. Then I have to divide this by 7,400. Okay? And then I have to multiply by 100, right, to get a percentage. So times 100. And this is 8.1%. So this was 8.1%. Okay, and is that an increase or a decrease? That's a decrease, 8.1% decrease. Okay, let's continue with this idea. Absolute and relative change. Okay, absolute and relative change. Okay, given two quantities, absolute change equals the ending quantity minus the starting quantity, and that's absolute values. Just means everything's positive. If I end up with a negative, I just make it positive. The relative change, okay, the relative change, which is basically the percent increase or decrease, okay, is the absolute change over the starting quantity. So it's basically the same formula that I just gave you. Just make sure that all of your numerators are positive. Okay, all of the numbers on top are positive. Okay, because we don't want any negative percentages. Okay, example 1.5. The US federal debt at the end of 2001 was $5.77 trillion and grew to $6.2 trillion by the end of 2002. At the end of 2005, it was 7.9 trillion and grew to 8.45 trillion. Calculate the absolute relative increase for 2001 to 2002 and for 2005-2006. Which year saw a larger increase in the federal debt? Okay, so we just want the percent increase for each of these. Percent increase. So I'm going to go, okay, the difference between 2001 and 2002, that's 6.20, so 2001 to 2002. 6.20 minus 5.77, absolute value, all over the original, which is 5.77. Okay, that's the starting quantity. Okay, so difference over original. Okay, difference over original. Okay, so this is going to be equal to what? Let's go to the calculator real quick. 6.2 minus 5.77. Okay, hit enter. I always hit enter because if I don't, I'm going to get the wrong answer. Okay, so it's very heartbreaking when students know how to do the problem, but they enter it into the calculator wrong, right? So if I wanted to do this all at once, well, let me just continue with this, and then we're going to divide by the original amount, which was what, 5.77, right? Okay, hit enter. So this is going to be, okay, 7.5%. We could then multiply by 100 to get our percentage, and it's 7.5%, right? 7.5% increase. Okay, so let's go back here. 7.5% increase. 7.5% increase. Now, the other way that I can do this on the calculator is to use parentheses. Notice that there's a big difference in my answer. There's a big difference in my answer if I do this. 6.2 minus 5.77 divided by 5.77. That gives me 5.2. What did I do wrong there? What did I do wrong? I should have come out with the same answer as above, well, 2 steps above. What did I do wrong here?
There are no parentheses where they're supposed to be at in the equation.
Yeah, I didn't add the parentheses to the numerator, right? Fractions are implied parentheses. We do everything on top, we do everything on bottom, and then at the very end, we divide. We do the top, we do the bottom, and then we divide. So in order for the calculator to understand that we're doing a fraction, we have to tell the calculator, do everything on top, do everything on bottom, and then divide. So I'm going to put the parentheses in this time, 6.2 minus 5.77 divided by 5.77. And this time it comes out with the correct answer. Multiply that by 100, and we get 7.45%. Okay, so make sure that you're doing that correctly. Okay, let's go to 2005, 2006. Okay, 2005, 2006. 2005 to 2006. What's the difference? The difference is going to be 8.45 minus 7.91 over the original, which is 7.91, absolute value. Okay, absolute value of a positive number is still a positive number. So this is going to be what percent increase? What is the percent increase going to be here? 8.45 minus 7.91. Okay, and then I'm going to divide that by 7.91. And what's the percent increase? Anybody get the percent increase? Yes, no? 6.8, thank you, Lily. Yes, 6.8% increase. So which year had the highest rise between the two? Which year saw the largest increase? Yeah, 2001 to 2002, right? 2001 to 2002 saw the largest increase. This is larger. Okay, exactly. Perfect. Okay, let's move on. Proportions and, I skip one? Oh yeah, let's do this one. A politician's support increases from 40% to 50%. Describe the change. Okay, so it goes from 40% to 50%. Okay, so what's the percent increase? What's the percent increase? Well, that's going to be 0.4 minus 0.5 absolute value over 0.4, right? That's the original. Well, what's 0.4 minus 0.5? Isn't that negative 0.1? And what's negative 0.1? What's the absolute value of negative 0.1? Wasn't that just 0.1? And what's 0.1 divided by 0.4? Well, I could really, if I wanted to, I could multiply both top and bottom by 10. That gives me 1 over 4, which gives me 0.25, which gives me 25%. So it was a 25% increase. Okay, makes sense? Okay, if I go too fast, let me know. Okay, but again, this is just review. We're just reviewing some concepts. Okay. Okay, let's get into rates and proportions. Okay, let's get into some rates and proportions here. Okay, let's see what we got here. Your car can drive 338 miles on a tank of 26 gallons. Express the relationship as a rate. And this is really going to be a unit rate. Unit rate, okay, which is always per something. Okay, it's like miles per gallon, miles per hour. Okay, per means for each or for every one. Okay, per is for each. Okay, for each one. Okay, so 27 miles for each gallon. 27 miles for each hour. Okay, that's what per means. Okay, so we're going to say 338 miles to 26 gallons is equal to what? Well, let's just divide. 338 divided by 26 is 13 miles per gallon. Okay, is that good mileage or bad mileage?
Bad, I think. Yeah, bad.
Bad, yeah, that's pretty bad. That's pretty bad. Yeah, that's like my truck used to get 13 miles per gallon. That's really, really bad. Okay. My car, my Ford Fusion, gets 40 miles to the gallon. So I went from 13 miles to the gallon to 40 miles to the gallon. So a good savings in gas. Okay. Okay, proportions. Let's look at proportions. Let's solve for x. Anybody know what we're going to do here to solve for x? On this proportion, we want to solve for x. Okay, anybody know what it's called? Okay, yeah, thank you, Ricardo. Cross multiply. So 17x is equal to 3 times 85. Divide by 17. We get x is equal to what? Well, 17 goes into 85 5 times. Do you know that? So if I reduce this, this goes 1 and 5. 17 goes into 85 5 times. What's 3 times 5? It's 15, right? So x was 15. Okay. A crepe recipe calls for 2 eggs, 1 cup of flour, and 1 cup of milk. How much flour would you use if you used 5 eggs? So 2 eggs to 1 cup of flour, right? To 1 cup of flour is going to be equal to 5 eggs to X cups of flour. Does that make sense? 2 eggs per 1 cup of flour is equal to 5 eggs per X cups of flour. What are we going to do? Cross multiply and divide. Cross multiply. 2x is equal to 5 times 1. Divide by 2, and x equals 2.5 cups of flour. That's it. Easy. Easy breezy. Easy peasy. Easy cheesy. Whatever you want to say, the easy is with the rhyming. Okay. Okay. So easy, breezy, beautiful cover girl. whatever you want to say. Okay, let's move on. Okay, a highway had a landslide where 3,000 cubic yards of material fell on the road, requiring 200 dump truck loads to clear. Okay, so 300 yards and 200 trucks. Okay, another highway slide left 40,000 yards cubed. How many trucks did it take for that? Right, again, let's cross multiply and divide. 3,000 times X is equal to 40,000 times 200. Divide by 3,000. And X is approximately what? We're going to get 40,000, okay, times, okay, 200, divided by 3,000. Okay, and it's saying that it's about 2,666.6 loads. Okay, so what would my answer be? If X comes out to be approximately 2,666.66 forever, just 0.6 forever, how many loads, how many truckloads am I going to have? How many truckloads am I going to have here? Well, no matter how much is left over, don't I need another truckload to go get whatever's left over? Does that make sense? That 2,666 trucks is not going to get all of the dirt. We have to have 2,667 trucks. See, Alex make sense of that, right? So even if this was, we're not rounding here, even if this was a 3, how many truckloads would we need? Wouldn't we need the same number of truckloads? Because if I took 2,666 truckloads, I still wouldn't be left with everything. I'd have to have a little bit left over. I'd have to have that extra truckload. That make sense? So this is really 2,667 truckloads. It's hard to learn from your house, right? There are a lot of distractions. Yeah, there is. One, it's really hot. That's a distraction. One, you got your little brothers and sisters running around. That's a distraction. You got your parents coming in and disrupting you. That's a distraction. It's very distracting. So try to block it all out as much as you can. Okay, dimensional analysis. Let's say, how do we deal with proportions when it comes to dealing with the changing dimensions here, right? Changing dimensions. How are we gonna go from centimeters to meters, or centimeters to inches, right? How would we change the dimensions here? It's traveling 12 miles per hour. How many feet per hour is this? How many feet per hour is this? Okay, so I'm going to set this up as a proportion. 12 miles in 1 hour, right? Okay, and feet. Does anybody know how many feet are in a mile? Anybody know how many feet are in a mile? Those of you that want to be engineers? Right, 5,280, very good. So where's the feet going to go? Is the feet going to go on top, or is the feet going to go on bottom? Yeah, the feet goes on top. Why? Because I want the miles to cancel. Does that make sense? I want the miles to cancel out. So the feet goes on top. So this is 500,280 feet to 1 mile. And so the dimensions, that's why this is called dimensional analysis, the dimensions cancel out. Does that make sense? Dimensions here are going to cancel out. Oh, okay. So I'm just going to get 12 times 5,280. If you plug that into a calculator, you get 63,360 feet in 1 hour or per hour. Okay, 63,360 feet per hour. Nice. Okay, B, next, convert feet per hour to feet per second. Okay, so convert the feet per hour into feet per second. Okay, so we've got 63,360 feet in 1 hour, and we want to convert this to feet per second. Okay, so where's the seconds going to go? Are the seconds going to go on the top or the bottom? We want feet per second. Feet per second. Are the seconds going to go on the top or the bottom? I want to cancel out the hours. Okay, where are the seconds going to go? The seconds are actually going to go on the bottom. Why? Why are they going to go on the bottom? Because I want to know in 1 hour how many seconds that I have. And so the hours cancel. Does that make sense? The hours cancel. Does anybody know how many seconds are in an hour? Anybody have any idea how many seconds are in an hour? Well, there's 60 minutes in an hour, and there's 60 seconds in a minute. So what's 60 times 60? Yep, thank you, Edsel. Okay, ooh, Edsel is here. Edsel? Wait, no, that's a different person. Okay, yes, 3,600. So we're going to take this 63,600, we're going to divide by 3,600, and when I do that, I get 17.6 feet per second. What does this tell me? That tells me that 12 miles per hour is equal to 17.6 feet per second. Does that make sense? So if I'm running at 12 miles per hour, I'm actually traveling 17 feet every second. That's kind of cool. Do you know what 60?
How did you get the 17.6? That's where I'm a bit.
I just divided. I went to my calculator when you weren't looking, because I'm like the Flash. And I went to my calculator when you weren't looking. I went 63,600, and I divided by 3,600 seconds, and I got 17.6 feet per second here, or 17.7. Oh, you know what? I did this wrong. This is 63,360 divided by 3,600. Boom. There, 70.6 exactly. Okay? Does that make sense?
Yes, thank you.
Now, most people don't know that they run 17.6 feet per second. But most people do know that, I don't know what I just did here. What the frick? Go back here. Okay, there we go. Okay, but most people do know that if I go 60 miles per hour, that's 88 feet per second. Well, that's kind of cool. And engineers know this. 60 miles per hour is 88 feet per second. Oh, that's cool. Cool. Right? Could we have gotten that easy? Could we have gotten that easily? Sure, what's 12 times 5? What's 12 times 5? 60, right? Isn't it 60? Okay, what's 17.6 times 5? Isn't that 88? Yeah, yeah. How many minutes are in an hour? How many minutes are in an hour? 60. So if I went 60 miles per hour, oh, okay, 60 miles per hour, isn't that 1 mile per minute? Isn't that 1 mile per minute? If I'm traveling 60 miles per hour in a car, then aren't I traveling 1 mile per minute? Yeah. And if you're going 1 mile every minute, how many feet are you traveling every second? If you go 1 mile per minute, then you're traveling 88 feet per second. That's kind of cool. Okay, how many feet will a bicycle travel in 50 seconds? Okay, how many feet will the bicycle travel in 50 seconds? Okay, so we got to set up. Okay, I know that it's 17.6 feet for every 1 second. If I multiply by 50 seconds, what cancels out? What cancels out here? Yeah, thank you, Alex. It's the seconds. And so what's left over? It's the feet. It's the feet. And so this is 880 feet is how far that travels. Okay. A 1,000 foot spool of bare 12 gauge copper wire weighs 19.8 pounds. So 19.8 pounds, so 1,000 feet. Okay, how much would an 18-inch spool of this? Okay, 18-inch spool of 12 gauge copper wire. Okay, so 18 inches. Well, I'm going to change the 18 inches into feet. How do I change the 18 inches into feet? Well, aren't there 12 inches? Right, so there's 12 inches, so 18 inches times 1 foot per 12 inches, right? There's 12 inches here. Well, 18 inches divided by 12, 18 divided by 12, that's 1.5 feet. Does that make sense? That's 1.5 feet. Yep, very good, Josue. Very good. Okay, so if that's 1.5 feet, and I want to know how many pounds this is going to be for 1.5 feet, I'm going to go X on top is the pounds, and 1.5 feet is on the bottom here, because I have to do pounds to feet, pounds to feet, pounds to feet, pounds to feet. Oh, okay. Okay. Interesting. Interesting. Okay, the other thing that we need to figure out, well, we'll do this first. We'll do this first. Okay, we'll find out how many pounds this is, right? Pounds. Okay, and then we're gonna have to change it to ounces. Okay, okay. Let's first figure out the poundage, and then we'll change it to ounces. So let's cross multiply. Well, this is going to be 1,000x is equal to 19.8 times 1.5. 19.8 times 1.5. Divide by 1,000. Okay, and x is equal to plug this into my calculator. 19.8 times 1.5 divided by 1,000 is 0.0297. Okay, 0.0297, I believe. Okay. And then this is the pounds, right? The pounds. So how can I change pounds into ounces? Does anybody know how many ounces are in a pound? Anybody know how many ounces are in 1 pound? 16. Very good. Thank you, Sean. 16 ounces are in a pound. Okay. So let's take our 0.0297 and we're going to say that that's the pounds. So what do I want pounds? I want pounds to be on the bottom, right? I want pounds to be on the bottom. And so I'm going to take this 0.0297 and multiply by the 16 ounces so that I'm left with ounces. The pounds are going to cancel out. So this is going to be times 16. And this equals 0.4752 ounces, or a little under half an ounce. 0.4752 ounces, okay, or again, a little under half an ounce. Okay. Okay, cool. Makes sense? Sorry for my chicken scratch here. 0.4752 ounces. Okay, let's move on to 1.3, geometry. Okay, pi r squared is the area of a circle. Perimeter area of a rectangle is length times width. Perimeter is 2L times 2H. Okay, the circumference is 2 pi r, or we could write that as C is equal to pi times the diameter, pi d. Okay, my daughter just had her Sweet 16 party on Saturday. She just turned 16. Okay. So, so my daughter, she just turned 16, had her Sweet 16 party. So I'll show you a picture real quick of my daughter at her Sweet 16 party. This is relevant, so just tune back in, okay? Trust me, there's a point to this. Not just the fact that my daughter had a Sweet 16 party, but she did have a Sweet 16 party on Saturday, okay? Because she's Sweet 16. If you're from Mexico, you'd have a quinceañera. Is that how you say that? Something like that. Okay, something. Yes. Okay. So you would do this a year before. It's the coming out of a young woman saying, "Hey, I'm a young adult. I'm an adolescent, and so here I am." I guess 300 years ago it'd be like, "Okay, marry me off," right? I'm old enough to get married. But in our culture, we're like, no, you're not. You're young and you're stupid, and you need to stay in school and do something more than just raise your children. So we don't say marry them off at 15 anymore. Okay, that's old school. Okay, but different cultures had different ages, and I guess in the last 40 years we've been celebrating this thing called the Sweet 16. So like, oh, Sweet 16. So, where'd my photos go? Okay, so recents. Nope, I want my recent photos, please. There we go. Okay, so this was her at her Sweet 16 party. I don't know if you can see that or not. That's her. That's my daughter at her Sweet 16 party. Okay, so she had her Sweet 16 party. Boom, boom, boom. Okay, big nice little chair. We had to have it outside. That's a grill outside. So we rented the big chair and we did it outside in the park because we all had to be socially distanced. So that was her at her Sweet 16. So we bought her balloons and stuff. There's another one, Sweet 16, right? And this is her grandma. This right here is her grandma, okay? And this is who I want to talk about, okay? Nana Maggie is what we call her. Nana Maggie, she's the one that made the cake here for my daughter, okay? So Nana Maggie calls me up, my mother-in-law. She calls me up on Friday. She's freaking out. She's completely freaking out. She says, Jason. I said, what? Jason's my first name. She doesn't call me professor, which is what you guys are supposed to call me. She calls me Jason because we're tight like that. Okay, I've been married to her daughter for 20 years, so we're pretty tight. Okay, so she says, Jason, I have no idea how to do this problem. I'm like, what are you talking about, Maggie? She says, I built the cake and I need to put the trim, the lace trim around the cake. But I don't know how much lace trim to use. I said, okay, well, I said, can you measure the top of the cake, right? So she's got this cake, right? And I said, okay, Maggie, just measure the top of the cake. And she says, okay, I can do that. She says the top of the cake measured 7 inches, right? Measured 7 inches. So let me go back to sharing my screen here. Okay, so share the screen. Okay, everybody see the screen now? Okay, so here's my cake, my lovely cake that my daughter had on her Sweet 16 birthday outside in the park. Okay, with all the homeless people. We invited all the homeless people to her Sweet 16 because she has no friends. No, I'm just kidding. She's a very popular girl. So seven inches across, right? And so she wanted to know how much lace trim she needed to cut to go around this cake, right? So it was like lace trim to go around the cake. And I'm like, okay, here's what you do, Maggie. Here's what you do. This is a true story. This happened last Friday. I said, here's what you do. You got to take the length across and you got to multiply it by what? You got to take the length across 7 inches. You got to multiply it. Well, you got to multiply it by 3.14. What's that called? What's 3.14 called?
Pi.
Pi. Exactly. So by doing that, what are we going to get? We're going to get 7 times pi, right? 7 times pi, and so I go 7 times, and this is a true story, okay, times pi is 21.98 inches. Does that make sense? 21.98 inches? Okay. 21.98 inches. Okay, and so basically, if I told her just round to 22 inches, that's basically 22 inches, right? So I'm like, oh, okay, that's 22 inches. And I said to her this, I said, Maggie, do you realize that you are a baker that doesn't know pi? Do you realize that you're a baker that doesn't know pi? Just think about that for a second. Okay, it might hit you in the funny place. It hit me in my funny place. She's a baker that doesn't know pi. That's hilarious. That's hilarity. Like, there are very few math jokes in the world because math is boring. Okay, so when you get a math joke, you got to share it. This is a true story. I didn't make this stuff up. I can't make this stuff up. I'm not that creative. But Maggie, do you realize you're a baker that she didn't know pi? That was sad. Sad for her. Okay, anyway. That's good. Okay. Thank you, Romeo. I appreciate the courtesy laugh. I do. It may not help your grade, but it can't hurt your grade. Okay, I'm just letting you know that right now. It may not help your grade, but it sure can't hurt it. I appreciate the courtesy laughs. Okay, do you realize that you're a baker that doesn't know pie? And she thought that was funny too. She gets me. She gets my humor. She feels me right here in the heart. Say that again?
Can you stop repeating the same joke?
No, it's a different audience.
No.
Come here. Come here. You want to contribute and you want to tell me to stop repeating the same joke.
You're screaming the same joke. I'm like,
Come here. Do you want to say hi to the class? Okay, good. Go back to your room.
I'm just saying.
Be gone with you and your badness. It's a boring joke. I get it. Okay, it's my joke, not your joke. Leave me alone. Go back to your room. Go back to your whatever you do. I don't know what are you doing? You watching something? I don't know. Anyway, call him a bum again. Yeah, you lazy bum. Exactly. Okay. Don't you have homework to work on? Yes. Stop. Okay. I thought it was funny. She's a baker that doesn't know pie. That's funny. It's funny stuff. Okay, anyway. Forget it. Forget it. My humor is wasted on you. Wasted. Okay. Let's move on, shall we? Okay, 10-inch diameter pizza requires 12 ounces of dough. How much dough is needed for a 14-inch pizza? 12 ounces, 10-inch. Let me mute whoever's not muted. Okay. Are we supposed to go to 325 or 330? I'm confused. Because on the roll sheet it says 330, but somebody told me 325. So is it 330? What were you guys told? 330. Okay, good. Okay, thank you. Awesome. Perfect. Okay, sweet. We're all on the same page. Okay, perfect. Okay, so we have the pizza dough here. Okay, 10-inch diameter. Okay, 10-inch diameter, and it requires 12 ounces of dough. 12 ounces of dough. Now, we also have a 14-inch diameter pizza. And we want to know how many ounces of dough this is going to take. Okay, the problem is that the dough is a volume. Okay, it's a volume, but we're going to treat it as an area, right? Because when we make pizza, we just kind of flatten it out, right? But the ounces are a volume. It's a mass. It's how much mass is there. So when we flatten it out, we're going to treat it as if it was an area. So if you tried to do this, 10 to 12 is equal to 14 to x, you would get this wrong. Okay, this is wrong. Okay, this makes me unhappy. Okay, that's wrong. Not good. Okay. Okay. Why? Because we're not relating the diameters to the ounces because it's not a linear unit. Ounces are not linear. Ounces are volume. How much volume of pizza I have here. Okay. And so what we're going to have to do for this one is we're going to have to take and find the area to the ounces is equal to the area to the ounces. Okay, the area to the ounces, area to the ounces. And so this is going to be pi r squared. What's the radius? The radius is 5 squared to 12 is equal to the area here, which is pi times 7 squared, pi r squared, to x. Okay, so cross multiply. I get 25x pi is equal to 49 pi times 12. Divide by 25 pi. The pi's cancel out. Okay, and x is equal to 49. 49 times 12 divided by 25 is 23.52 ounces. Boom, that one's done. Okay, volume. What's the volume? The website says 48 50-pound bags of sand are needed to fill a sandbox. That measures 8 by 8 by 1. How many bags of sand, how many bags are needed for a sandbox that measures 6 by 4 by 1? Well, we're just going to multiply to find the volume. Okay, 8 times 8 times 1 is 64. 6 times 4 times 1 is 24. So I know that 64 cubic feet requires 48 pounds of sand. 48 50-pound bags. Okay, 48 bags. Okay, is equal to 24 cubic feet over x bags. We're going to cross multiply. This is 64x is equal to 24 times 48. Divide by 64. And x is equal to 24 times 48 divided by 64 is 18 bags of sand. Okay. Okay, it's right there, 18 bags of sand. Okay. Okay, last example. Okay, a grocery store has bulk pecans on sale. Okay, which is a great, since the baker is planning on making 10 pecan pies for a wedding. The recipe calls for 1 3/4 cups. However, in the bulk section, there's only a scale available, not a measuring cup. Okay. The baker runs over to the baking aisle and finds a bag of pecans and looks at the nutrition label to gather some info. How many pounds of pecans should the baker purchase? Okay, so 1 3/4 cups, right? Okay. How many cups do we need? Well, we need 10 times 1 3/4. So 1 3/4 is 1.75. I'm going to multiply that by 10. That's going to give me 17.5 cups total that I need for the pecans here. Okay, how many pounds do I need? Well, 1 cup is 99 grams. Okay, so we have 75.5 cups. Okay, and so 1 cup is 99 grams. Okay. Okay. 1 cup is, this is in grams and not pounds. Okay, and so what we need is we need to know that the conversion from grams to pounds, grams, is that they're in 1 pound. Okay, 1 pound is 453.6 grams. We'll just round it to 454 grams. Okay, there are 454 grams, and you could look that up on the internet by Googling that. Okay, there are 454 grams per pound. Okay. So I'm going to cancel out these guys, and I'm going to say, 17.5 times 99 over 454 is going to give me the pounds. Does that make sense? The pounds. So 17.5 times 99 divided by 454 is 3.8 pounds of pecans. 3.816 pounds of pecans. Okay. Now, don't take off anywhere. I know it's 3:30. I'm going to end here. Okay, I am going to give you some homework. So please, you can print this off, take a picture of it, and then email it to me. Okay? So, oh my gosh. So let me stop my sharing. Stop sharing. Okay, sharing is caring. I'm gonna give you guys, where's my chat here? Okay, I wanna do everyone. I'm gonna file share. Okay, this is your homework. Okay, this is your homework. Until you get on Canvas, this is going to be your homework. Okay, again, what are the instructions? Print it off or download it, write out your answers on it, and then take a picture and send it to me. Does that make sense? Okay. And so let me
Did
give
you
you,
print it? Because I can't see it.
I'm giving it to you right now.
Oh, okie dokie.
Okay, right now I'm giving it to you. Okay, so here should be the file. Okay, this is chapter 1 practice. So if you could download that file, okay, save it somewhere safe, and then you're going to want to print this off, or you can, if you have a tablet or a touch screen computer, you can just write directly on it with your finger or a stylus, save it, and then send it to me in an email. Okay? Do you not? It's in the chat. It's in the chat. Look in the chat. Yes, it is due before. It is due Sunday night at 9 o'clock. Okay? It's due Sunday night at 9 p.m. You don't see it in the chat? Did nobody get it from me? Scroll up. Is it not there? Somebody want to talk to me?
I got the file. Yeah.
What? It should say M105 practice chapter 1. Okay? Were you able to get it in the chat? If you didn't get it in the chat, just email me and I'll send you a copy.
Okay. Yeah, because I don't have it either. Okay then.
Okay, I will see you guys Monday. You're going to hear from me before then, as soon as you get Canvas access, okay?
Mhm.
Okay.
Thank you so much.
You're welcome. See you guys later.
Appreciate the joke. I actually laughed.
Sure. They get funnier. Trust me. These are the bad ones in the beginning. They get funnier.
Okay. Don't worry.
Stick with me.
Okay.
Okay, bye.
Bye.